Hello everybody, Horizon Language Schools family welcomes you. Today we will study fundamental forces in nature. To understand the meaning of force, let's study this activity. Activity number 1, try to push a wall by your hands. What do you observe? The observation, the wall doesn't move because the force acting on the object is improper. Number 2, why do these objects remain static? Because there is no force acting on them. Lift the book by your hand. What do you observe? The object move because the force acting on them is proper. Watch what happens for the moving ball when the goalkeeper catches it. The moving ball stops. Why? It stops its motion because the force acting on an object can stop its motion. What happens when a racket hits a tennis ball? The ball changes its direction because the force acting on an object and change its direction. And so the object moves when a proper force acts on it. To change the state of the object from static state to motion or vice versa, or to change the motion direction. So the force is an effective attempt to change the object state from being state to motion or vice versa, or attempt to change the motion direction. So the force change the object state from being static to motion or vice versa, or change the direction. So the measuring unit of the force is Newton. Give reason. The static car doesn't move when you try to move it because the force acting on it is improper to move it. Fundamental forces in nature. There are many different types of forces. These forces can't be seen, but we can feel them in some phenomena. What these phenomena? Lightning, thunder, wind motion, the attraction, and to attraction. The attraction of object to earth, attraction of iron to magnet. So the phenomena which illustrate the force are lightning, thunder, wind motion, the attraction of object to earth, attraction of iron to magnet. Okay, forces causing technological application is fire weapons, generating the electric current, اللي هو electromagnetic force, nuclear explosions, nuclear reactors. So we can study the fundamental forces in nature, which are 3 types. Number 1, gravitational forces. Number 2, electromagnetic forces. Number 3, nuclear forces, which are 2 types: weak nuclear forces, strong nuclear forces. Today we will study gravitational force. What is the scientist who discovered gravitational force? Is Isaac Newton. Once he was sitting under a tree, as we seen, but the apple fell on his head. When the apple fell on his head, if we will eat the apple, but he kept thinking. Then he proved that all masses are attracted towards the earth itself by a force known as Earth's gravitational force. And this force depends on the masses of the object. So the factor affect the gravitational force is the mass of the object. This is the first factor. Okay, let's see the following activity. There are 3 different masses. What is the observation? The exerted work to lift object increase by increasing the object masses. What we conclude from this? As the object mass increase, the work done to lift the object upward increase also in the opposite direction of Earth's gravitational force. So the object weight is the ability of Earth to attract that object to its center, or another definition is the force of Earth, the force of Earth's gravitational to the object. So if the weight is force, so the measuring unit is Newton as the force measuring unit. So the measuring unit of the object weight is Newton. And the law of object weight equal object mass by Earth's gravitational acceleration. Acceleration is measured unit by m per second square. And object mass is kilogram. So the weight W equal m by g. And so what is the factors affecting the weight? Two factors which are in the law: mass and gravitational acceleration. Again, the factors affecting object weight are object mass, number 2, gravitational acceleration. The effective point of an object weight is located at its center, and this is known as center of gravity. So it says that the Earth attracts the object toward its center, which is the center of gravity. Okay, problems with each other. Calculate the weight of an object if its mass is 100 kilogram, if the Earth's gravity acceleration is 9.8 meters per second square. The solution, number 1, write the relation. It is very important. Weight equal mass by Earth's gravity acceleration equal 100 by 9.8 equal 980 Newton. Problem number 2, calculate the mass of an object if its weight is 280 Newton, knowing that the Earth's gravity acceleration is 10 meters per second square. Solution, the relation weight equal mass by Earth's gravity acceleration, but we need the mass. So mass equal weight divided by Earth's gravity acceleration equal 280 divided 10 equal 28. What is the measuring unit? Not Newton. This is mass, 28 kilogram. Okay. Problem number 3. A big box has number small balls that are similar in mass. If you know that similar in mass, this is NB. The mass of one ball is 0.5 kilogram. The weight of balls equal 500 Newton. The Earth's gravitational acceleration equal 10 meters per second square. What is the solution? I have three number of small balls. I don't have the number. Okay. The mass of one ball 0.5. The weight of balls, all balls, equal 500. So the weight of one ball equal the mass of one ball by Earth's gravity acceleration. So 0.5 by 10 equal 5 Newton. The number of balls, how? Weight of balls, all balls, divided by weight of one ball. So I can get the number of balls, which is 500 divided 5 equal 100 ball. Okay. Notice, object mass is fixed. The object mass is fixed or constant value. Doesn't change ever. But object weight changes from place to another due to Earth's gravitational acceleration. Another factor in this relation of object weight, the Earth's gravitational acceleration, it changes from place to another. With the Earth's gravitational acceleration, it changes from place to another, not constant. The object mass is constant, but the weight and the gravitational acceleration not constant. The value of Earth's gravitational acceleration changes from one place to another. How? This person, let's notice, the weight of this person differ from one place on the Earth, in the same Earth, okay, from one place to another. Okay, the gravitational acceleration also it change in this point, change in this point. تمام. In this point, the weight of the man is 983, but in this point is 983 Newton, but in this point the weight is 978 Newton. Why? What is the difference? The difference in distance between the object and center of the earth. So the difference, distance different from this distance. So the gravity decreases as we move away from the center of the earth, and as we approach, the gravity increases. So the first factor, approach or moving away from the center of the earth. Earth's gravitational acceleration decreases by moving away from the earth center and raising up the surface of the earth. Okay, number 2, increase by approaching to the earth center on getting down towards the surface of the earth. The first factor, approaching or moving away from the center of the earth. Number 2, the second factor, transfer from one place to another on the earth surface. Okay, due to the difference of the distance between the earth surface and its center from place to another. Why? The earth, as you study in social, the earth not spherical, non-spherical shape, but it's oval, slightly oval. So the distance between the center of the earth and any point on earth surface at the two poles, north and south poles, is less than the distance between the center of the earth and any point on the equator. This point, this distance, is this in the pole and this in the equator. Okay, يبقى this distance is less than this distance. The distance between earth and any point on earth surface at the two poles is less than the distance between the center of the earth and any point on the earth surface at the equator. Okay. The weight of the man, its mass is 100 kilogram. Okay, at the North Pole is more than its weight at the equator. But at the North Pole is 978 and the North Pole is 983, the equator, sorry. The Earth's gravitational acceleration at the two poles is more than at the equator. At the two poles is more than at the equator. And this is the same result of the first factor. And thus we have finished our lesson today. I'll send you a short sheet, please answer it, and if anyone doesn't understand something, send me. Thank you. Regards, Miss Sarah.